Welcome to video 2 on circles. So in the last video, recall that we derived the equation for the circle by essentially using the Pythagorean theorem. We said that the circle is the set of all points that are equidistant from a fixed point. Okay, so we came up with x squared plus y squared equals r squared. And this equation is very important because in Algebra 2, you remember that every function you learned about had a parent function. So it's going to be similar here. Every conic section that we learn about is going to have a parent. And in this case, the parent circle, which technically isn't a function, right? It's a relation because you could see the circle does not pass the vertical line test. But every conic section is going to have a parent. So x squared plus y squared equals r squared is the equation for the parent circle. And very importantly, all parents have to live at the origin. So what's crucial about this is that the center of this particular circle is 0, 0, okay? And the radius is r. It doesn't have to be 1. That would be the unit circle. It just has to be some generic value r. Okay, now what's really, really important about circles that you have to understand is that when you have a circle, and in order to have a circle mathematically, it is crucial that the term in front of x squared and y squared, or sorry, the coefficient in front of the x squared and y squared match, and that they're both positive. If those conditions are not met, you will not have a circle. So for example, I have a positive 1 in front of x squared, and I have a positive 1 in front of y squared. That will make a circle. Now, what's interesting is I could do this. I could do 2x squared plus 2y squared equals 2r squared. Now, you can see mathematically that this equation is actually the exact same as this one here. This is the exact same circle. The reason is, if I had a 2 in front of every term, right, I could just divide by 2, perfectly legal, and get back to where I started. Okay, so having a 2 in front isn't going to change the actual circle. It will look exactly the same. So interestingly, these numbers in front, as long as they all match, they will not change the value of the original circle. Now, I want to show you on Desmos. I did a little graph so you can actually see this in real life. So let me just take this off the tripod here. And I'm going to show you on Desmos how this is going to work. Okay, so I encourage you to also get this out and try it on your own. So here I've graphed x squared plus y squared equals r squared. And I'm going to just make the radius 1 to keep it simple. So you can see here, this is my graph, right? Now what's interesting is, if I put a 2 in front, or a 5, or any other number, let me just go to my next page. So here you'll see what I did, right? I put a 5x squared plus 5y squared equals 5r squared. And I also graphed the original circle. You're going to see that these two things are exactly the same. So if you look over here, right, it's exactly the same. It didn't change the value of the circle because those coefficients could be divided and get me back to the same thing. Okay, now, interestingly, let me just try something here. I'm going to delete this one. Right, if I were to do, like, instead of positive terms, let's say I put a negative here, now I'm not a circle anymore, right? I violated the definition of a circle. To be a circle, the coefficients in front of x squared and y squared both have to be positive. So look what you find if you do this, right? This is actually a hyperbola. We'll get into those later. All right, now let's go back. And I encourage you to, go on Desmos and just play around with this. This will be kind of interesting. If I make the mismatch, like for example, let's say I have a 2 in front of the x squared, right? This is no longer going to be a circle because everything's going to be a little crooked, okay? So if I put a 2 here, you're going to see that I have an ellipse, right? So it's very crucial that you understand that to be a circle, I need the term or coefficient in front of the x squared term, the coefficient in front of the y squared term to match and to be positive. Okay, so that's super, super, super important. I will see you in the next video.